The first thing that we want to remember with our distribution is that when something is squared, like root 8 plus root 3 squared, that means root 8 plus root 3 times by itself. And when you have two binomials multiplied by itself, you're going to have to, in English, we use the word FOIL. Now, FOIL is just a reminder that we multiply our first ones, we multiply the outside ones, the inside ones, and the last ones. So in English, we use this because it helps us remember. Wow, if we can spell inside. So you might hear someone doing math in English and they'll say, oh, you just need to FOIL. But if you don't know what that means, like foil is like metal paper, you're like, why do we need that for math? Well, this is it's just to help you remember the order you need to multiply things in. So when I multiply root 8 times root 8, I get root 64. And root 64 is just 8. So when you have a square root times a square root and the number is the same, you will just get 8 plus root 8 times root 3, root 24. And another root 3 times root 8 is another root 24. And then root 3 times root 3, you could write root 9, but that'll just be plus 3. And so after multiplying these out, we've got to do the same thing we did in section 2.3, is simplify this. Well, I can put 8 and 3 together. That makes 11. And I can put root 24 and root 24 together. That would be 2 root 24s. Should I get full marks? No. I shouldn't. What do I still need to do? I have to reduce the root 24 in its simplest form. So what are two numbers that multiply to give me 24, where one of them is a perfect square? 6 and 4. I'll put the 4 first. So now I have 11 plus, well, square root of 4 is 2. 2 times 2, 4. And there's my final answer. You could do the same thing for the second one. I'll only do one of those. But now, we're going to do one of these in B as well. So again, if I FOIL this one out, those ones, those ones, those ones, and those ones. Root 8 times root 8 is 8. Root 8 times root 3 plus root 24. Negative root 3 times root 8. And negative root 3 times positive root 3. What does this simplify to? 5. Nice. I really like that answer. All of the crazy square roots just disappeared. Why does that happen? Do you recognize what's happening in here compared to some algebra that you've done in the past? What does it remind you of? It's like X what? Can you give me an example of algebra that this is like? No. It's like in algebra if you had x squared minus y squared. If you had to factor that, it'll be x plus y, x minus y. Okay? What did we call that kind of factoring in grade 10? Confusing. Nice. Do you remember the name that this was? The name of this type of factoring? See, sometimes we give things names because if we remember the name, it also helps us remember how to do it. And if we don't remember the name, chances are we won't remember how to do it. This is a difference of squares. Does that ring a bell when we talk about it now? No? Never did factoring any differences of squares? Nice. Okay, difference of squares. So when something squared minus something else squared, the difference means subtraction. So when you have that minus sign between, that's why it's a difference. And since both of them are squares, we call it a difference of squares. If we want to get fancy in our language, when you have one binomial that's x plus y and one binomial that's x minus y, those two binomials are called conjugates of each other. Now that might be a word if you didn't remember I'd be okay with. But the difference of squares, that should be something that you remember. And if not, you just learned it now, and so you have till tomorrow to have it memorized. So you're good. Tomorrow's Friday. So I'm back on track. Right? All day I thought today was Friday. Now you have till tomorrow. Make sure you know difference of squares. So if you were asked to factor x squared minus 9, it's equal to x plus 3, x minus 3. And whenever you have a difference of squares, whenever you multiply them, like if I'm going to multiply x plus 5 times x minus 5, something special happens. When I FOIL, the first one's multiply to give me x squared. But every single time, can you see that your outside, minus 5x, and your inside, plus 5x, cancel out? Just like they did here. And when I multiply the last ones, 5 times 5, 5 times the negative 25, I get negative 25. Now this becomes powerful for square roots because whenever you have square roots, and one of them is positive and negative, and you multiply by the same thing with a different sign, all your square roots will go away. Because it'll just be the first one squared, which is 8, minus the last one squared, which is 3. The middle values will go away, and you'll just get a whole number in the end. And that's going to come up later, because we're going to find out with radicals that you cannot have a square root on the bottom of a fraction. It's not considered simplified. And one of the things we're going to have to do, here's a bunch of big words, something called rationalizing the denominator. Sound like fun? It's not that bad, but this is the trickiest part of it, knowing when to multiply by the conjugate. So this just introduces you to the idea that something special happens when you multiply two binomials where one is positive, one is negative. If the square roots are the same, all the square roots disappear. So let's go to example 1. In example A, we just want to multiply them out. So I'm going to rewrite them. 4 root 2 plus 2 root 5, 3 root 2 minus root 5. And we have to FOIL. So the first thing that comes up in this question is how do you multiply mixed radicals together? Well, multiplying mixed radicals together, we multiply the coefficients, which are the numbers. So when I multiply 4 root 2 times 3 root 2, I'm going to get 4 times 3 is 12. And you multiply your square roots. What's root 2 times root 2? And right now, it's okay to write root 4. Even if you know that that's 2, let's write it as root 4 right now. So I multiplied my numbers in front together. 4 times 3 is 12. I multiplied my square roots together. Square root of 2 times square root of 2 is 4. On my outside one, I have 4 root 2 times a negative root 5. Well, 4 times a negative 1 would be negative 4. And my square roots, root 2 times root 5, root 10. On the inside, I have 2 root 5s multiplied by 3 root 2s. 2 times 3 will be 6. Root 5 times root 2 will be root 10. And finally, I have 2 root 5s minus a negative root 5. 2 times a negative 1 would be negative 2. And root 5 times root 5 will be the square root of 25. What's 12 root 4 really equal to? Well, root 4 is 2, and 2 times 12 is 24. Can you see that these two are like radicals? So 6 root 10s minus 4 root 10s will leave me with 2 root 10s. And minus 2 times the root 25 is really minus 2 times 5, negative 10. Do we have any like terms here? 24 minus 10, 14. Can I simplify 2 root 10? No. For simplifying, it is equal to root 40. But we remember that when a radical is simplified when it's listed as a mixed radical. So when we have a choice between changing it to root 40 or leaving it as 2 root 2, we would leave it as 2 root 2 because that's simplified. Everybody good with A? So all right if I just make it a little bit smaller to make some space? Put it over here. And we'll go right beside and do B. Okay. Anybody able to do the mental math and see that it's 20? No, not yet? Whew. Okay, well, let's do it slowly then. If we multiplied it out, the first ones together, the last ones together, the inside ones, the first one's the outside, the inside, and the last. When I multiply the first ones, well, 4 times 4 would be 16. Root 2 times root 2 would be square root of 4. Outside, 4 times the negative 2 would be negative 8. Root 2 times root 3, root 6. Inside, 2 times 4 is positive 8. Root 3 times root 2, root 6. And the outside, 2 times negative 2 would be negative 4. Root 3 times root 3 would be root 9. Any like terms? Yes. These ones beautifully disappear. 16 times root 4, well, square root of 4 is 2. 2 times 16, 32. Square root of 9 is 3. Negative 4 times 3, negative 12. Put those together, and we get 20. How did I do that in my head? First of all, I noticed that it was a difference of squares. They were exactly the same numbers. One was positive, one was negative. So that's a conjugate. So I know it's going to be the first one squared, which will just be 16 times 2, 32. The second one squared, 4 times 3 is 12, and they'll be subtracting. So recognizing that pattern, making that connection to the difference of squares, allowed me to find a shortcut to do that quicker. But it's not wrong to multiply it out and simplify as we go. Okay, practice some of these. 3, 4, 5, and 7.